Hello class, welcome to this video on the Chapter 4 Lesson 1 quiz review. So we're going to go over one of the versions of the quiz. I hope this video is useful to you. So let's go ahead and get started. So for each of the following situations involving sampling, identify the population that the sample represents. So all you got to do is just identify the population. Okay, so a business school teacher, a researcher wants to know what factors affect the survival and success of small businesses. She selects a sample of 150 eating and drinking establishments from those listed in the telephone directory for a large city. So in this case, the population here are all the small businesses. She wants to see the look at the factors affecting survival and successes of small businesses, right? So population is all small businesses. Okay, so if you said that, then that's good. That's fine. So a member of Congress wants to know whether his constituents support proposed legislation on health care. His staff reports that 228 letters have been received on the subject, of which 193 oppose the legislation. So we got a member of Congress wanting to look at his constituents, right? He wants to know whether his constituents support legislation. So the population is all the congressman's constituents. It's all congressmen's constituents. All right. So now, all right. So local radio talk show hosts asked viewers to call in and vote for or against a proposed plan to raise the prices charged by municipal parking meters in a downtown shopping district. 75% of the respondents are opposed to the increase. Describe one possible source of error or bias that might arise in this poll and indicate the direction in which the estimate might be biased. What is the name for this kind of bias? Okay, so it's a radio show. They did an open invitation to for anybody to vote for or against a plan, right? So generally, if the people that are actually going to call in are those that of the people listening to the show have strong opinions, about the issue, and so they have a strong enough opinion that they feel like they need to call in, right? And so this is probably going to overestimate the 75% is probably an overestimate, okay, because of these people that have strong opinions, right, that are calling in compared to the average population. All right, and this is a voluntary response because we have people that are responding to an open invitation. They self-select themselves or they volunteer to be in the poll, right? So, for number 2, we're saying only those listeners with strong opinions are more likely to call in. Therefore, the 75% is likely an overestimate of those who actually are opposed to the increase. Okay, and then this poll, what is the name for this kind of bias? This bias arises from voluntary response. Since viewers self-select themselves to participate in response to an open invitation. Okay, so if you said something like what we mentioned earlier, or anything like this, then you get credit for the question. Okay, there's a few parts to this question, right? There's different questions that they're asking in number 2. All right, so number 3, 2 different organizations conduct polls in a city whose mayor has been accused of taking bribes. One poll asks a simple random sample of city residents, do you think the mayor should resign because of accusations of his criminal activity? The other asks, do you think the mayor should resign? The first poll concluded that the majority of city residents think the mayor should resign, and then the second poll drew exactly the opposite conclusion. Explain why the results might be so different. Well, according to the wording of the question, those that read the question, do you think that they should resign because of accusations of his criminal activity, that would elicit a more negative response than if they had not included the wording, right? And so therefore they would have the poll would have drawn opposite conclusions, right, based off of that. Okay, so we'll say the wording of the questions are different enough that we would get different responses. The first poll that included the info about accusations of criminal activity would have elicited more negative responses than the second poll. Which attributes to the opposite conclusion, to the opposite conclusions of both polls. Okay, so this is just a wording, but if you said anything like that, where the wording of the survey and the fact that they included the info about accusations, criminal activity, that would have enabled responses to be more biased in the negative direction, right? Or have more negative responses, right? And then therefore leading to the opposite conclusions. So anything like that, so these questions are not necessarily, they're not difficult. It's just a matter of being able to explain. So your school will send a delegation of 35 seniors to a student life convention. 200 girls and 150 boys are eligible to be chosen. If a sample of 20 girls and a separate sample of 15 boys are each selected randomly, it gives each senior the same chance to be chosen to attend the convention. Is it an SRS? And explain. All right, so this is not a simple random sample because you're splitting the population into 2 groups, right? And you have, in this case, based off of gender, so based off of male, female, boys, girls, so that's when you split up a population into groups, automatically you should think a different type of sampling method, right? So not simple random sampling. You should think the other two, like for example, stratified, right? And also in addition, a simple random sample, what you would do is you would pull these people together, the 350 eligibles, and then you would number them, right? So you would number all of them, and then you would select them. Now, when you select them randomly, there is a chance that you would have a group with just all girls, or just all boys. And this is just not possible with the method that they did here, right? Because you have a group of 20 girls and a group of 15 boys. So that's not possible. And that would be possible in an SRS, right? For this question, we're saying no. We're going to say no, it's not an SRS. Since not every group of seniors is equally likely to be selected. And we mean every group, meaning it's not possible, for example, to get all boys or all girls, which would be possible in an SRS, even though it's random, it can happen, right? It could still happen. There's a chance, which is not possible with this method, right? So equally likely to be selected. For example, it's not possible to get a group of all girls with this method, right? With the current method. The seniors were split into two groups. Then were chosen randomly from each group. Which is a stratified random sample. So it's not a simple random sample, it's a stratified random sample. Okay, so if you just mentioned that it's not an SRS because, of this whole, that fact that, not everybody's going to be selected because, or that you have the two groups, right, that split, and then you're polling people for each group randomly, and you mentioned that it's a stratified sample, right? That's key, mentioning that what kind of sample method it is. Then you'll be fine. Now explain clearly how you would use your calculator to choose a sample of 20 girls for this study. Now, you don't have to, I mentioned on the day of the quiz that for your calculator, for this question, technically they're looking for a calculator command in order to do this. However, in order for you to get credit for this question, you don't necessarily have to use a calculator command. You can say how you would use technology, right, to choose a sample of 20 girls, like technology in general, right? Like how would you use a random number generator to choose a sample of 20 girls? So you don't have to be specific here. However, I will be specific in this question, so that way you know how to actually answer the question that they're asking. Okay, so explain clearly how you would use your calculator to choose a sample of 20 girls. So let me just kind of explain how you would do it if you're just talking about random number generator. You would say number the girls from 1 to 20, right, or 1 to 200 because there's 200 girls. So yeah, number the girls from 1 to 200, and then use a random number generator to select girls until 20, or to select different numbers from 1 to 20, or from 1 to 200, I'm sorry, between 1 and 200, until 20 different numbers have been selected, right? So choose 20 different numbers from 1 to 200. And then select those girls corresponding to those numbers, right, for the study. So something like that. So that would be the generic response. But here I'm gonna be more specific and say I'm gonna include the step for the calculator. All right. All right. So number on the girls from 1 to 200. Use a random number generator. And I'm going to put that in parentheses for the calculator, okay? You use the command rand int 1, 200. So this is on the calculator, right? Use that command, so that way you know what that command is. So I'm going to underline that. To use random number generator to generate numbers, or generate 20. Let me use the word here, sorry. 20 different numbers from, or between 1 and 200. Select the girls corresponding to each of the numbers selected or generated. Okay, so this includes the random number generator stuff, right? The generic stuff that we shown, but also includes the calculator command. Now, if you did not include the calculator command, I'm gonna still give you full credit for it, but you still want to make sure to understand that, just so that you know how to do it if they ask for the calculator. All right, but if you did the rest of this, then you should be fine. All right, part C. Beginning at line 108 in the random digits table, reproduced below, select the first 3 senior girls to be in the sample. Explain your procedures clearly. Okay, so first off, let's explain the procedure. What do we select? It says beginning at line 108, so we got to begin here. So explain your procedures clearly. So first things first, we want to select from 1 to 200. So therefore, we're trying to go. We're looking at the first 3-digit numbers, right? For this. So so if we read, we read the table. From left to right. Looking at the first, we want 3 senior girls, the first 3 3-digit numbers between 001 and 200. So if you said something like that, where you need to look for between 001 and 200 for 3-digit numbers, to get. All right, so now we're gonna do it. So first 3 3-digit numbers, the first 3 different or no repeats. If you said different or no repeats, right? I forgot to include that. The first 3 different 3-digit numbers, or first 3 unique 3-digit numbers, or first 3 3-digit numbers between 001 and 200, no repeats, right? Let me put no repeat. So you can also do that, no repeat. All right, so here we go. So we got, these are the 3-digit numbers. Let's split them up. Okay, So 609, that's not a number that we can select. And also we want to ignore, between 001 and 200. So 407, no. 202, no. 417, no. 868, no. 249, we keep going. 436, no. 179, we can choose that one, right? So 179. So I'm going to circle that. 090, that's 90, so yes. 656, no. 879, no. 641, no. 888, no. 336, no. Now we got 009, so we can choose that, and that's 3. Okay, and then that's how you would do it. So you just explain how you did it, and give me your random sample. All right, that's gonna do it for the video, guys. I hope you found this useful and informative. And as usual, I'll see you in the next one.